All right, so in Chapter 2, Section 4, we're dealing with complex numbers, and so that's when we have i's, imaginary numbers. Typically, complex numbers in this form, a plus bi. So all real numbers can be put in this form. It's like if I said the number 12, a is 12, but there'd be no imaginary part. So if we have a complex number, we're just going to put it where it has this real part and its imaginary part. So looking at number 2, so in standard form would be a plus bi. So we have our real part and the square root of 36. Square root of 36 is 6, and then the square root of negative 1 is I. So we have 1 plus 6i. If we're looking at something like number 5, setting that up, this is just, you can collect like terms. So 8 minus 4 gives me 4, and negative 12, well, that means it's going to have some imaginary part to it. And 12 is 4 times 3, so it's equivalent to this 2 root 3. But there's just some I because of that negative 1 on the inside of the root symbol. So these would actually cancel each other out on my problem and would get 4. Looking at something like number 8, write the quotient in standard form. Well, to get it in this form, what you have to do is rationalize the denominator. So when you worked with roots in the past, if you had a root in the denominator, you were asked to sometimes rationalize the denominator. And that means you'd have to multiply it by some root. Well, here, to put this in standard form, we'd have to multiply top and bottom by the conjugate. So for this one, we'd have to multiply the conjugate of 4 minus 6i is 4 plus 6i. And the nice thing about that, like when you do a 4 minus 6i, and then you multiply it by a 4 plus 6i, your 4's gives you 16 when you do that p 6i times the 4, and that 4 times 6i, those cancel out because the signs will be different. But then we're going to get a negative 36i squared. And so if you think about negative 36, and then I is root negative 1, so we're going to square that because that's what I is. Desmos does not do well with imaginary numbers, but root negative 1 times root negative 1 becomes negative 1, so I squared is negative 1. I believe in your book it'll talk about how imaginary numbers, they're cyclical. They come back around. Let's see if I can find that in the text, and we can look at that. Because again, once we get to I to the fourth would be positive 1. Doo-doo-doo. Might not be in here, but if I is root negative 1 and then you square it, you would just get the thing inside, so that would be negative 1. So if for a problem like this, that's why on the bottom we'd have a 16, and then we'd have a, I guess it would be a plus 36 eventually. Let's look at Desmos again. Because if I have positive 16 and I have a negative 36i squared, which would make it positive 36, it would give me a 16 and 36 is 52. And so what's happening, why my answers are 2/13 is probably because there's some reduction that goes on. And that's reduction wise, we would get these values. With WebAssign, unless it says to reduce, you don't necessarily have to reduce, unless it says to. But it does want an exact answer, so please do not give a decimal number. I think y'all probably already figured that out. And then lastly, let's look at number 11. So this one's asking to use the quadratic formula. And I put it up here, I wrote it on one of those supplements. But this is a quadratic formula. Again, when we're dealing with ax squared plus bx plus c, this would be the two answers. We'd have negative b plus or minus the square root of b squared minus 4ac all over 2a. So it's asking us to use the quadratic formula to solve. And so we have our a, we have our b, we have our c. And when we're doing these, it appears that we are getting some complex solutions. So if we look at x squared plus 4x plus 5, let's look at it as a graph. So if you look at x squared plus 4x plus 5, we see the graph doesn't have any x-intercepts. So it doesn't have any real solutions, but since it's a squared, it has solutions. It's just that we have two imaginary solutions. And so that's why working through that, the quadratic formula, on this one you see that it has two solutions, negative 2 minus I and negative 2 plus I. So it does have two solutions, they're just not real solutions. If they were real solutions, we'd cross the x-axis. So that should give you a start with the section for material.